Hello everyone, and welcome back to another video. I'm going to be doing another LeetCode problem on linked lists. This one might either be my last one before I move to like a different topic, or I might do another problem and then move on to a different topic. Now the next topic could be something like linked list still, but like circular, or I can move on to like stack or queues. Things like that. But for now, let's just focus on this. Okay, so this is a LeetCode 203, remove linked list elements, and it's an easy problem. I'm gonna write the code down and I'm gonna explain it. So it's gonna be the same as always. Write everything down and then explain it afterward. Okay, so first, we have a remove linked list element. Given the head of a linked list and an integer val, remove all the nodes of the linked list that has node.val equals val, and then return the new head. So basically, we're gonna have a list node, or basically a list, and then there's gonna be a value that they're gonna put in, and they're expecting the value that we find to be removed. So let's create a list node called dummy. And that's going to be a new list with 0 and head. Okay. And then we're going to have list node prev, and that's going to be equal to dummy. Another list node, and we're going to call it current, and that's going to be equal to head. Boom, boom, boom. Let's create a while statement. While current is not equal to null, we're going to write an if statement, which is current.val. If current.val is equal to val, then we're going to skip it. By skipping it, we put pre.next equals current.next. Oops. Now, obviously, you should have an else statement. What if the current value is not equal to the value that we're looking for? When that happens, then prev equals current. And we put current equals current.next. That's to help us move forward, basically, with the next number, next value, next node. And after that, we return dummy.next. And that should be it. Okay, so let's write down the comments. The dummy node is just dummy node, so it should be easy. Last kept node for prev. Node we're checking. This is the node that we're checking, which is current. And right now it's pointing ahead. The while statement will just be walk the list. We're walking through the list. We're checking. This if statement is we're checking if we need to remove this. If yes, then skip. If no, keep it and move pre forward. This part, always move current forward. As long as the while statement is true, the current will keep moving forward. And then this is the new head. So basically, we first make a tiny fake node, which is dummy, and that dummy is going to be pointing to the head. So this makes deleting the real first node, like the first real node, easy, right? We're going to walk through the list with 2 pointers, which is basically prev. It's the last node we're keeping, and the current, which is the node we're checking. So if current.val is equal to val, we basically skip it. There's not really a way to, instead of removing it, we just need to skip over it and then go to the next node. It's a lot easier that way. So that's why we have the pre.next equal to current.next, right? And then obviously there's an else, like if the current value is not equal to the value we're looking for, then we keep it and just move forward. with the prev, and after moving forward the prev, you move the current forward to the current.next. But the current.next is gonna keep moving forward as long as the while is true. The while statement is true. It doesn't matter for the if and else statement. That part, it doesn't care. It just keep moving forward until current is equal to null. And when that happens, the while statement ends, and then you return dummy.next. And that's dummy.next is gonna be the new head, you know? So, and with that, let's write down the time and space. So time complexity, very easy, O of n. Because all you're doing is you're going through the list, and you only go through once. So look at each node once. Space, O of 1. That's it. Because all you have is just a few pointers and a dummy node. And that's it. Just a few pointers. Nothing else. We run it, see if it's correct. Accept, yep. And then we submit. And then that should be good. And there it is. Not bad, I guess, yeah. Yeah, and then for obviously our example 1 should be easy to understand. You know, you see the val like 6, the value is 6. When it sees 6, the pointer is just gonna point to the next one. With the 6 on the very end, it's gonna point to null instead, basically skipping the node 6, you know, with the node with the value of 6. If the head is empty, that means this while statement is never true. And just because the current is gonna be pointing at null already, meaning if it's not true, all you're doing is you're returning nothing. Now with the 7, the while statement is gonna be true, and then the if statement is gonna be true the entire time. And then so basically it's gonna keep skipping 7, 7, 7, 7, and then it's gonna point at null, meaning the while statement is no longer true, and all you're returning is same thing, nothing, empty. And that's it. Yeah. Thanks for watching.